I think it's just going to be just incredible. I see moon bases in the near future. I see Mars bases in the near future. And I like to think of those as like your gas stations. And in some cases, they might be if we are able to develop that technology, if we're able to use the resources on these, other planetary bodies. And, once you get to that little step away from Earth, whether that's the moon, whether that's Mars, you start opening up more accessible areas of our solar system and of space.
What can you learn from building the first micro-lunar rover? Hello and welcome to Tech First. My name is John Koetsier. In January of this year, Peregrine Mission One launched with something like 22 different payloads. One of those was intended to be the first American-made rover to land on the moon since the Apollo days, 1972. It was called Iris. This was the first lunar rover constructed with carbon fiber. It was designed and built by students at Carnegie Mellon University, and today we're going to chat with them. Welcome, Harsh, Kevin, and Carmen. Thank you for being here.
Pleasure.
Thank you, John. Thank you. Awesome to be here.
Awesome. Super pumped to have you guys. Maybe let's start here. And I don't even know who to talk to about this, but maybe Kevin, will give it to you first. What was Iris intended to do?
Our goal was to launch what would be the smallest and lightest lunar rover to ever go to space, which is something that at the time we did succeed in doing. And our goal was to, first and foremost, show that students are capable of achieving such a task and do so at what is a relatively low budget compared with typical space missions. And our goal is to kind of pave the way for future space programs at Carnegie Mellon University, as well as other universities and organizations, and just take these little steps towards democratizing space for all.
Cool. Carmen, this is not easy stuff. I know because my son is an engineer and he participated in some of these types of challenges, including going to Shanghai for some robotics challenges when he was in university. And it's easy to make something that sucks. It's hard to make something that is good, and especially for a harsh environment like the moon.
For sure, yeah. And, that is definitely a challenge that we had to face. We did a lot of different testing on our rover to make sure that it could, deal with the difficult nature of space. There are a few tests that have to happen that, all rovers and everything that goes to space has to pass these tests. That could be like a vibration test because, when the powerful rockets or the powerful engines on a rocket go off, you have to be able to survive that. And that's true of anything that has to go to space. And then being a lunar rover, we had to survive. We're also the first lunar rover to be dropped as our deployment from the lander as opposed to, rolled out or lowered down. So that was some testing that we had to do. And, we succeeded in doing that here on Earth. We unfortunately weren't able to test at least our deployment mechanism in space, but we were able to, survive the launch. Our systems survive some of the harshest places in space, at least between here and the moon, including the Van Allen belt. And, a lot of the things that we used in our rover, a lot of our electrical components and stuff are not technically space grade. They're not like industry standard. They're all custom and just normal stuff. And it survived and it did well.
Super interesting. Maybe Harsh will bring you in here because yours was the first lunar rover designed with carbon fiber. That's really interesting because I know a little bit about carbon fiber. I mean, a little bit. Right? A little bit. But I did talk to Nathan Myhrvold, who's a former CTO of Microsoft, and he talked about building cameras to photograph snowflakes. And the key challenge with that is that the camera has to be very cold because guess what? You'll evaporate the snowflake, you'll melt it very, very quickly. And so he ended up building much of his assembly out of carbon fiber because it doesn't contract or expand in cold or heat. Was that one thought with using carbon fiber as well as the weight for you guys?
Our mission was to be the ultra low cost, and carbon fiber being a strong material which could withstand all of the conditions that you just spoke about. That was one of our decision to make it of carbon fiber. So it takes off the low weight, which ultimately reduces the overall cost of the launch, which was one of our aim as well, to be an ultra low cost rover. So that decision supported our goal.
Cool. What did you guys do? What were your guys' roles? Kevin, maybe we'll start with you. We'll just go around in the same order.
Yeah, sounds great. I had a variety of roles on the project. When I first came in, I was helping out with mission operations. At the time, we were building out our mission control center, which is actually located in our Gates School of Computer Science. And so we were remodeling that and really adding in the screens, the computers, and figuring out how we'd integrate that with the mission simulations that we'd been running in order to make sure that for the actual mission, we'd be able to have all the procedures and designs in place in order to make sure we can run a very smooth mission, akin to what you would see in the movies for like NASA's control center and the sort. And after that, I helped out with the media team as well, representation. And when I was there, I helped with designing and maintaining our Shopify store. And later on during the mission itself, I was in Florida with the mission team as we went through what would be a very long series of events. And we'll definitely get into that.
It's amazing how many jobs there are. There's a lot of different pieces. Carmen, what did you do?
Yeah, on a similar vein, I wear multiple hats in this organization as well, where I, similar to Kevin, have worked as a mission operator, joining in a big wave of recruitment for the project once we were getting close to, a potential launch date and a mission date after that. So I joined as an operator and again, developing kind of what operations would look like on the surface of the moon, because we have this incredible work of engineering, but we need a team to run it. So joining, working that out, kind of coming up with some constraints that we might put into place, some pipelines of communication within the team, what kind of roles do we want to have, etc. And then on top of that, I worked my way up to representation team lead. So working on public relations things, information, being the face of, kind of leading the face of the project to the general public, helping, with Kevin, us working together, social media, interviews, talking to, reporters after our mission happened. And
Cool. For the first part of what you were saying, the picture that was coming in my mind was one of my favorite movies is The Martian. And it's that team that they had to pull that old team out. How do we talk to this thing? How do we communicate? What process? What commands do we send? All that stuff. So very cool. I just noticed you and Kevin are wearing a particular kind of jacket with some patches and stuff like that. It looks pretty cool. It looks really pretty official. I don't know if you're in a motorcycle gang or maybe it was from. It's probably the mission jacket. Is that correct, Carmen?
yes, it is correct. All of our mission operators who are there for all of our training and the mission were able to get an official operator jacket here.
Sweet, sweet. Harsh, what was your role? What did you do?
Sure. So I was an early contributor along with Kevin, Carmen for the Carnegie Mellon Mission Control, and then I joined with the team for our launch and was one of the mission operator. I was also the practicum leader for space mission engineering.
Let's go back in time and let's assume that it's going to work and it's successful and it lands and it's on the moon and it's traveling around. Your rover is actually functioning. You're an operator, you're a controller, you're telling it where to go, you're checking out craters and boulders and all that stuff. What were you hoping to learn? What were you hoping to accomplish?
Yeah, great question. So some of the scientific goals of Iris as a rover were to just kind of test the terra mechanics of how tiny nano rovers work on the moon. Because, one of the next big steps in space travel is how can we use the moon? How can we use that to our advantage? Where NASA's going to be sending more astronauts there. There's talks of setting up bases there. We need small little devices there that can move around, maybe future transportation of small goods, etc. So this is like the first big step in that, is testing how small scale can we get and still be effective. So Iris was only about 20 centimeters in length, very small, shoebox size, little rover. And the wheels, comparatively, and the wheels are made of carbon fiber as well for that flexibility aspect. So it was really kind of testing that. How do these, what we call nano rovers, work with the moon? Yeah, that was the biggest thing, really, is testing that, capturing images on top of that, and just kind of, learning our environment. What's the threshold of a rover this size? Because that's a lot of what we found in our research as well. Is, some of the sizes of obstacles that we were considering, like nobody had ever had to, think about those before. Because the next smallest lunar rovers were kind of like SUV sized. So our little thing, like, that would be a huge obstacle. A smaller rock that a car size rover would have to deal with is nothing. Where our rover, it would be pretty big deal. So yeah, just kind of testing how all that works, capturing some images on our way, and ultimately also proving the feasibility of having students be able to do this. And as Kevin was saying earlier, open this up to more than just, government and long-standing professionals.
Super interesting. I mean, and what's really, really cool to me is like before we landed on the moon, there was a lot of talk about what we're going to find in terms of how we're going to get around. Some people thought, hey, there's a huge layer of dust there, perhaps, especially in the Mara areas, right? The lunar seas, quote unquote, and you could just sink, right? And so others were, no, you won't. But with such a tiny machine, you wonder, I mean, did you ever consider something like grasshopper mode, like extend the wheels really quickly, flick yourself over a big obstacle? I mean, you can have a lot of fun with different options, right? Especially when you're building small. It's not necessarily insanely expensive to try stuff.
I know earlier in CMU robotics, there are some rovers that have kind of like a spider effect where they have legs that will pick up and move. But we really wanted to just test out kind of a more standard method of transportation, just wheels. It's a, keep it
Hey,
simple,
they've been
stupid,
around a long time. They have a long track record. They're pretty effective. So Kevin, let's bring you back in here. Carmen talked about what you would have accomplished, what you hoped to accomplish. Obviously, the mission failed, not through any fault of your own, but the craft that you were operating on, that you were a passenger on, had a fault and did not ultimately make it to the moon. They had to crash land it in an ocean somewhere. But your mission was not entirely a failure. It's not like you got no results. What results did you actually accomplish, even though you didn't land on the moon?
The amount of data scientifically that we collected was very significant given what probably most people would expect, given what ended up happening to the rover itself. I'd say, in terms of the largest technological achievement I think we accomplished, was firstly just the fact that the primary systems during launch and transit survived extreme temperatures, high radiation, specifically through the Van Allen belt, and we verified that all the systems were operational. And for a nano rover of this size, that is quite an accomplishment. And these were done in space. During transit to the moon, we were able actually to connect and have two-way communication between the lander and rover, where we ran test commands and telemetry, and we transmitted a large amount of data, including downlinking a large file that actually included the names of everyone who was actually involved in Iris over the years. So that was one of the largest achievements we managed to have. I myself did manage to send some messages of my own to the rover in space and receive them back, which was very cool.
So that's kind of interesting. Actually, more than kind of. That's kind of crazy because often we think, okay, you're sending up a craft. It's got an autonomous mode, semi-autonomous mode, and then there's a command mode where you can tell it where to do stuff. And often when you send a craft, then you hear, okay, NASA's lander or craft landed on Mars. Now they're sending commands. Now it's responding. Like it unfolds its antenna or its dish or something like that and starts sending. But you were able to do that while your craft was packed away. It was in the box. It was inside the spacecraft, and you were still able to communicate with it, and it was able to communicate back.
That's correct. Our rover, fortunately it's not. We didn't intend for it to be a satellite, so it doesn't have, for example, significant solar panels that need to be unfolded in order to receive power. Actually, the modules inside of the lander, which required power, were connected with power during the flight in order to make sure that the telemetry could be verified and that the batteries would remain charged up until the moment of landing. And so we were fortunate in that case to actually have access to the rover and be able to run these commands during flight once we learned that we maybe didn't need the battery power necessarily for the mission itself on the moon.
Cool.
And
Cool.
actually,
Harsh, go
could
ahead.
I actually add to something that you said there? Something unique about our rover and the way we were connected to our landers, we actually were not inside of it. We were attached to the outer part of the lander. So
You were a hitchhiker.
yeah, exactly. And I think that adds another layer of just excellence to what we achieved is that our rover more like was exposed to the pure vacuum of space during transit, and our systems survived all of that. And we were still able to send these massive files that Kevin had just mentioned. And so we weren't tucked away. We were actually on the outside, which is why we would have had the drop deployment if we had made it to the moon and stuff. But very cool.
The photos that Astrobotic, the lander company, which is also a CMU spinout, they tweeted, and we could see our rover's wheel in space along with stars in the background.
How close did the craft get to the moon? Did it circle the moon once, or was it still orbiting the Earth?
So we reached the lunar distance, but because of the propellant leak from the lander, we missed the moon. So where we were supposed to see the moon and enter the orbit, we could not do that. But we certainly did reach the lunar distance. And at that point of time, we saw the dust that was collected, and since we missed the moon, we had to come back to Earth. And while it was coming back, the photos were transmitted.
So you were the Apollo 13 of lunar landers, essentially. Return to sender. Okay,
Right.
super interesting.
And
It was
also America's first commercial lunar payload service mission, and I think America's last lunar mission was Apollo 17.
Yes, exactly. Kevin, talk about Astrobiotic, which is the company that was running the Peregrine missions. They are trying again. They realize that they failed. They're redeveloping, learning from their mistakes. They're trying again, I think, in November of 2024. Are you guys on it? Do you have another prototype? Do you have a working copy of what you build? Are you just gonna like bolt this one on too?
As of currently, I don't believe we have plans to have a copy of Iris sent out in the future. One of you guys, Harsh or Carmen, you can correct me if I'm wrong about this, but I don't believe we have a ticket on their 2024 mission currently. But I can definitely see in the future that we would love to write on them in the future. And definitely in terms of future payloads, we actually do have several different lunar missions at different stages from proposal to design to actually finished rovers as well that are just waiting for a ride to the moon.
Okay. So there's no refund on that that lunar ticket, huh? And there's no like, okay, we'll replace it with their second one. That's a little unfortunate. Too bad.
No insurance companies that I would say would be willing to take on risk that this high. So unfortunately, we don't have a policy claim on it.
Okay, okay. But Carmen, do you guys still have like you don't just make just one, did you? Did you make two of your rovers? I mean, I'm sure you had so many prototypes. Is there one that's almost exactly identical to what actually got sent up? Do you have another one hanging around somewhere in your back pocket?
So we don't have a, space grade one lying around. We have what we call our Earth model, which is an Earth replica meant for Earth conditions, such as Earth gravity, where the moon's
Mm.
gravity is 1/6 of Earth's. This one is meant to withstand, normal gravity, well, what we would call normal gravity. For example, one of the differences you would see is that the wheels are thicker on our Earth model, um, whereas the wheels on our flight rover were like quite literally paper thin. And to the point where we wouldn't leave it sitting in Earth gravity for too long for fear of the wheels collapsing, but they would work just fine up on the moon. So we don't have anything that's identical, mostly for cost purposes. Um,
Mhm.
as well as students still have to go to classes and stuff, whereas an industry professional, you know, would, have a full-time job dedicated to these kinds of projects. So,
Yeah,
there's a few
I get
reasons
it.
for not having a carbon copy of our
I
rover.
get it. I
Um,
get it. It's understandable. It's interesting though, because you mentioned, like the wheels on the Earth version are tougher and stronger. You guys have seen some of the Mars rovers that NASA sent up there. You've seen their wheels. I mean, obviously they've got what they put a 30-day lifespan, intended lifespan on them, right? And I think I'm sure they underestimate so they can beat it. But then some of them are going for a year, year and a half, and their wheels are beat up. I mean, talking holes in them all over the place. And you almost wonder it would be cool to have something up there that would be working and running for a long time. Anyways, let's get on to the future. What are you guys doing now? Are you guys still associated with the project? What impact has it had on your careers, your school, and what you're doing? Maybe Carmen, let's start with you.
yeah, sure thing. Me personally, I am actually continuing on with one of the next rovers that Kevin had mentioned. While we don't have an Iris 2.0, we do have some more rovers in development, including Moon Ranger, which is a rover also developed entirely at CMU, that is planned to look for lunar ice near the south pole of the moon. So that's a rover that's getting to the end of its development and hoping to hitch a ride in the near future to get a real lunar mission on that one as well. So currently I'm working on the mechanical team for um, one of our test rovers designed for our Earth conditions here. So that's what I'm currently working on.
Awesome, awesome. Anybody listening who's maybe working on Artemis or something like that, we're looking to hitch a ride here. Prior experience as a hitchhiker, very low mass, not a problem. Very, very cool. Awesome stuff. Kevin, what are you working on?
Yeah. Well, as Carmen mentioned before, I was also on the Moon Ranger team for a little bit before I joined Iris, and I can also agree on that point that we definitely are looking for a ride in the near future. So, if anyone just happens to have a rocket lying around that they haven't been using in a while, we'd love to pick one up. But definitely, jokes aside, I really have found Iris to be the defining event of my time at university. Being able to work on a project of this scope and of this importance at such a relatively young point in my career, I feel like has really changed my mind on what kind of effect I can have in industry as well. Although I don't believe I'm going directly into the space industry upon graduation, just knowing that I have had something like this already on my resume or already on my profile allows me to confidently say that anything on Earth I could probably do pretty well if we are already doing things that are going to the moon, right? So how hard could it be?
I'm signing you up for deep sea exploration development, and you have to personally test it. It's the only thing that's tougher than space. I'm not sure. Like you're harsh. What are you working on right now?
Right. So I transitioned from a student to an alumni. So Now, the involvement which I had with Iris for the next mission, I'm just working with the practicum leaders and the director of I&I to open up opportunities for our future students.
Cool. What's really cool about what you guys have told me is that you did something innovative, you created something. You also used off the shelf components in a lot of cases. And what's interesting about that is, I mean, the surface of the moon, what percentage have we touched it? It's got to be a 0.00001% or something like that, right? If we can drop a bunch of these on a lot of different places, especially if we're looking for water, we need some combustibles, we need some oxygen, we need some hydrogen, we want to fuel future rockets, we want to provide breathable air for lunarians or whatever we're going to call them, right? People are going to live on the surface. We need to find that. If we're just looking in one place at a time, that'll take forever. If you can have these cheap things that can last 4 weeks, 2 weeks, whatever it might be, and you can drop 1,000 of them, you increase your chances. So that's really, really cool. Carmen, maybe let's end with you a little bit. We're really in a golden age of space exploration. It's incredible, right? SpaceX is obviously leading that, but there's many other companies involved. We see the constellations of satellites that are just mind-boggling. If you think 10 years ago, even 5 years ago, and you'd say, there's thousands of privately owned satellites in space, people would laugh at you. They think you're insane. If you'd say, hey, there's a launch module that is bigger than anything that's ever happened before. It's designed to go to Mars, and they want to build like 1,000 of them and actually get immigrants to Mars and stuff like that. That people would laugh at you as well. There's a lot that is going to be possible, perhaps in the next 3, 5 years, 10 years, something like that. How do you see the future of aerospace? You worked on it a lot, and you're still working on it. How do you see the future of development and future of humanity in space?
Yeah, you're absolutely right. And I think, as you mentioned, all of these projects working up, I think, more and more people are going to start to get involved. You're already seeing it. We're proof of concept of that. And I think it's just going to be s- just incredible. I see moon bases in the near future. I see Mars bases in the near future. And I like to think of those as like your gas stations. And in some cases they might be, if we are able to develop that technology, if we're able to use the resources on these, other planetary bodies. And, once you get to that little step away from Earth, whether that's the moon, whether that's Mars, you start opening up more accessible areas of our solar system and of space. And whatever contribution that we all can make to that, whether it's our first attempt at a nano rover and being able to be one of the earliest concepts of as you say, like a little device to maybe transport some goods or search for materials, whatever that we can be in that larger just journey through space, we're happy to be it. And we're going to
Awesome.
keep working towards it.
And who's signing up for a ticket to Mars?
Maybe.